Okay, so here's going to be your solutions for April 27th. I am going to appear here in a minute, or am. Here's going to be your solutions for this April 27th. These came off of last year's AP Calculus test, and again, I think that things are going to be fairly similar to where they were, but we really just don't have a clue. I've got 3 suggestions based on things I'm seeing currently that I want to make sure get pointed out. First off, and they say this if you watch the video about how to submit stuff, would you make sure you submit your pictures in the proper order? They did ask you to go ahead and write like hey, page 1, if it's page 1, go ahead and put a 1 up in the top corner, label your pages. They're going to ask you to put your number on the page, all those kinds of things. So, anyway, try to submit your photos. If you are on multiple photos, submit them in order. And that brings me to the second one, which is I would definitely submit multiple photos. You're obviously going to submit different photos for the separate problems, and so maybe you won't have to do 2 for the same problem, because remember, you're going to go through one problem, then submit it, then you're going to go through the second problem, then submit it. Be careful, they also got a little trick in there, and I hope you watch the video on that, and that is that they say, oh, you got whatever, 25 minutes, then plus 5 to submit it. They're not going to tell you when that 25 runs out. They're going to put 30 minutes on the clock, and you're going to get a little 5-minute warning, and they are saying when it hits that 5-minute warning is when you should start submitting your stuff. Okay? So be careful that you're going to see 30 minutes, and don't say, oh, I got 30 plus 5. You have 25, and it must be submitted by 30. Now, that means if you are confident that you can get it submitted in 30 seconds, you have 29 minutes and 30 seconds. Don't do that. But also, okay, as far as number of pages, write bigger. All right, these are things I'm seeing. Sometimes I have a hard time searching your work down, or some of you get on that piece of paper and you try to cram everything in. And remember, you've got a grader that's looking for your work, and the clearer, more presentable that you can give them that information, the better your chances are that you're going to actually get your point awarded. Okay, so I'd almost even skip lines. Don't forget your equal signs, all that little detail stuff, because the whole test is written response now. Pay attention to the, are you using good fluent math notation? Are you going function notation? There is one particular person that really likes to do this and not name the function. Okay, those things you've got to avoid that, all right? Write big enough, write clear enough, okay? I've got some that like, hey, I've got this integral, and then you got a little 2 and a little 1, and they're really hard to see when they come across on pictures. So remember, you're communicating your information to a grader who's not in a situation that they're also accustomed to, and so they're not going to be comfortable with that as well. They're used to getting one part of a question on one full page. So understand that, if you start cramming everything into a piece of paper that's that big, then you're not helping yourself, and it would be my intent to have you actually help yourself and do well here. The third thing was going to be, landscape, portrait landscape. They want their pictures going up and down. Some of you do submit stuff, and it still comes in sideways, okay? And so that makes it difficult for them to read. My anticipation is that all of their graders are going to have an iPad. They're going to be at home, and these things are going to get sent to them. They're going to go through it with an Apple Pencil, just like I do in the classroom, and mark on it. And then they're going to send it on to the next grader, who's going to backup check it. And then ultimately, they're coming back to me. I'll get to see everything this year, which I'm kind of excited about. So I'll get to see your work, which is a first for this year, and hopefully it continues on year after. But anyway, all right, so I want to deal with this question. This is question 3 off of last year, just talking about the solution. You've got f that's a continuous function, goes from -6 to 5. Interestingly, they only show you it from -2 to 5. So there's a portion of the graph back here that we don't know about. It's centered, that circle is centered at 5, 3. We know that 3 minus root 5 is this point right here on the graph. That comes into play on part B. So anyway, here we go. Let's talk about part A. I'm going to do some setup stuff here. This is going to swing over to my iPad here in a minute so that I can also post this. So anyway, we write some stuff down. We know that the integral from negative 6 to 5 of f of x dx is 7. Okay, and we are searching for the integral from negative 6 to negative 2 of f of x dx. So, all right, so what they're looking for point-wise here is they wanted you to understand that we can piece these integrals together, and so they wanted something that would say that you understood that, that you understand, oh, it's just behind, okay? So what we'll do is we'll minimize that. That you understand that this plus this is going to equal the whole. And they're giving you the whole. So we could do this a couple ways. We could say, well, the integral from negative 6 to 5 of f of x dx equals the integral from negative 6 to negative 2 f of x dx plus the integral from negative 2 to 5 of f of x dx. Some version of that is getting you 1 point. Now, it doesn't have to be this form. A lot of you wrote it and said that this minus this part equals this part, or wrote it as this part minus that part. Any one of those is going to be okay. Anything that indicates that you understood that the two parts added together equal the whole, or the whole minus a part equals the other part. So it really doesn't matter. Okay. Let's do a little bit of stuff. So this right here was a +1 if you've got that somewhere. Okay, the integral from negative 6 to 5 of f of x dx is 7, so we're going to make that substitution. All right, and then let's see, we got to go through, or is that, let's double check that again. Is that what they've got given us here? Yep, they want us to find what is that. Okay, all right. So they want this part, which means we can calculate that part, which is going to also be worth a point. Now, you could write it out. I saw about 4 times where people wrote this out as integral from -2 to -1 of f of x dx plus integral from -1 to 0 f of x dx plus integral 0 to 2 f of x dx plus integral 2 to 5 f of x dx. Perfectly fine, perfectly fine. Personally, I would do something where I just maybe do this, okay? And again, you gotta pay attention to positives and negatives, but they're hoping that you looked at that positive triangle and that negative triangle canceled. That negative triangle and that positive triangle canceled. And so what you end up with is you start seeing, okay, well, I've got this little slice here, which that's 1 block, and if that block rotated down there, that's a full block. So that's 2 blocks, okay? So they were looking at you saying, okay, this little piece right here is worth 2, and then they wanted you to see that this piece is a square minus 1/4 of a circle with a radius of 3. So that square is obviously 9 units, so this piece here is going to be those 9 units subtracting, let's see, 1/4 of the circle, so and you do have to make sure to divide it, but that's going to be pi times 3 squared over 4, or 9 pi over 4. So that represents that area. Now they're both above the x-axis, so what we could do is we could come back to this and say that from -2 to 5 is going to be, I believe I had 2 plus 9 minus 9 pi over 4, and this is the integral of -6 to -2 f of x dx, okay? And we're really close. And now they are awarding one more point for you successfully finding this value. So this right here, worth a point, okay? And now we're gonna go 7 minus that quantity, and that's gonna get us our answer. So if we just wanted to say, hey, 7 minus the quantity, 2 plus 9 minus 9 pi over 4 equals the integral from minus 6 to minus 2 of f of x dx. That answer right there is going to get us another point. Now, many of us put it as, let's see, that's going to be 2 plus 9, 7 minus 11. So 11 minus 9 pi plus 4, or 9 pi minus over 4. Okay, something like that. Oh, and then notice too, minus a minus, it would actually be negative 4 plus, because we'd be a negative times a negative, so it'd be negative 4 plus 9 pi over 4. Again, all of those mistakes are possibilities, and you don't have to make them. You don't have to make that simplification. Okay? If you do this without the parentheses, you have a problem, and you've made mistakes, and you're going to lose your point for the answer. Things like that. Okay? All right, so that's that first part, part A. Let's advance to part B. Okay, so part B now says, okay, evaluate the integral from 3 to 5 of 2 f prime of x plus 4. Okay, so that's going to be 3 to 5 of 2. So they want to evaluate the integral from 3 to 5 of 2 f prime of x plus 4 with respect to x. Okay, now this one is about fundamental theorem of calculus. What they want to see out of this is, okay, let's integrate this first. So the integral of that, okay, so they wanted us to see, oh, the integral of 2 f prime of x. Well, the integral of f prime is f, so this is going to be 2 f of x plus the integral of 4, which would be 4x, okay, evaluated from 3 to 5. Okay. So I believe that was worth a point. Okay, something that showed that you could evaluate the problems that got made. Some of us saw this 4 and said, oh, it's a constant. We don't have to integrate it. Remember, that's if it's a derivative, you're taking the derivative of a constant, it goes away. But if you're doing the integral of a constant, it's going to turn into 4x or 4 whatever variable you're dealing with. Okay. Now, fundamental theorem of calculus says plug the 5 in and then plug the 3 in and subtract it. So we would be then looking at equals 2 times f of 5 plus 4 times 5 as a quantity minus 2 times f of 3 plus 4 times 3 as a quantity. Okay. And really all you need to do to finish this problem is plug in f of 5 and f of 3. So if we go and decide what is f of 5, well, f of 5, the value of the function at 5 is 0. All right, so we're going to plug that 0 in there. So I come back to that. Okay, I know, whoops, it was up. So f of 5 is 0, so this is now 2 times 0 plus 20 minus f of 3. Well, now there's where this comes into play, that at 3, the value is 3 minus root 5. So that means f of 3 is 3 minus root 5. So at that point, they are asking us, let's see, this is going to be 2 quantity 3 minus root 5 plus 12. And at that point, honestly, you could be done if you so chose, or you could continue to simplify as 20 minus the quantity 6 minus 2 root 5 plus 12. Let's see, 6 plus 12, so this is going to be 20 minus the quantity 18, take away 2 root 5, 20 minus 18, oh, that's 2 minus 2 root 5. But again, back up here, we could have been done right there if we so chose. Now, we could be done there too if we wanted to be. But, all right, so I know that was worth a point, and I think the fundamental theorem of calculus was also worth a point, which I think is that right here is what they were awarding a point for. Okay, so that gets you 2 more points. All right, part C. Okay. Part C is now saying, okay, the function g is given by g of x equaling the integral from -2 to x of f of t dt. That t is a dummy variable, just because they don't ever want the t and the x to match, so don't get thrown off by that. Find the absolute maximum value of g on the interval -2 to 5. Justify your answer. Okay, so this is an extreme value theorem thought, and they also want to make sure you consider the endpoints, but they also are interested in, I believe, it's going to be 1/2, but we'll check that. We'll check that out here in a minute. So, all right. So part C. Let me just write some stuff down before I switch it over. Okay. So as I switch it over, we want the absolute max value of that function on the interval -2 to 5. Okay, and let me quickly go back and check a minute. So we want to find the absolute maximum of g. Okay, fair enough. So that means we really only have to check -2, 5, and any points where we are a 0. And I think they awarded you a point for this statement. All right, well, g prime of x is going to be the derivative with respect to x is the integral from -2 of x of f of t dt. Fundamental theorem of calculus again, d dx of integral with x. Now, that should be a t there. I'll go ahead and change that. But that x is dropping in there, so g prime of x is f of x plus 1 point. If at any point you wrote that, or you established that you know that g prime is f of x, you get 1. Okay? Now, you have to say, well, absolute mins or maxes could potentially happen where g prime of x, which is equal to f of x, is 0. So we need to go back to the graph and decide where is the f of x function equal to 0. And I see 2 different places where that happens. I see -1 and 1/2. Okay? And obviously there's your 2 endpoints that you need to check, but we've got potentials at -1 and 1/2 that, all right, so we could say this happens where x is -1 and 1/2, and now we're ready to do a candidates test. So now we're ready to come through and do this, and we are doing the g function, and we are going from -2 to 5, so we're going to need to do -2, -1, 1/2, and 5. This is the justification of your answer. This is where you get shown that, hey, I knew that I had to check endpoints, and I had to check those critical points in between. So really what we're doing is we're using the candidates test. I think we end up eliminating those 3. So g of 2, g of 2 is going to be the integral from -2 to -2 of f of t dt, 0. Because if these match, we're going to 0. Okay. G of -1 is the integral from -2 to -1 of f of t dt, which is basically the area under the curve of f from -2 to 1. If I remember right, that's a positive half, right? From -2 to 1, it's a positive half. So we're going to fill that in with positive 1/2. G of 1/2 is going to be the integral from -2 to 1/2 f of t dt. Okay, so we got to look at that. So from -2 to 1/2, well, that's going to be, looks like negative something, right? Because that's a positive, that's a negative, it cancels. We're going to have that little bit of negative left over. Now, if you wanted to, you could say, oh, it's 1/2 times 1 divided by 2, that's 1/4. And so if you wanted to, you could say, well, this is negative 1/4. You could just eliminate it by saying it's less than 0, but whatever. g of 5 is the integral from minus 2 to 5 of f of t dt. I feel like we've done that, right? I feel like we've got that number somewhere. Boom, there it is, right there. The integral from negative 2 to 5 is 11 minus 9 pi over 4. So that's 11 minus 9 pi over 4. Okay? And that obviously then is the max. And so there's our justification, but we need to say G has an absolute max at x equals 5, and it is 11 minus 9 pi over 4. Okay, and the scoring on this worked for this way. You got 1 point for that. You got 1 point for considering 1/2. So if at any point you showed them that you knew you needed to check 1/2 as a potential max, and not even the -1, because if you look at -1, it's actually, well, I don't know why. They just chose that 1/2 or that 1/2. And then you got 1 point if you established it with the table as a justification, that candidates test. Okay? All right, so let's move forward here with that. So looking now at the next question. Okay? So functions f, g, and h are twice differentiable functions, with g of 2 equaling h of 2 equaling 4. The line y equals 4 plus 2/3 x minus 2 is the tangent to both the graphs of g at x equals 2 and the graph of h at x equals 2. Okay, find h prime of 2. All right, well that's pretty easy, it's worth 1 point. H prime of 2 is simply the slope of the tangent line. So the slope of the tangent line, and if you needed to put that into y equals mx plus b form, do any of that stuff, great. Otherwise, you could just recognize, oh, the slope is 2/3. So as we do that, all they are simply looking for, part A there, is that h prime of 2 is 2/3 plus 1. That right there, you did no work you needed to show, nothing that went with it. That statement worth a point. Okay? All right, let's see. Part B. Let A be the function given by a of x, 3x cubed h of x. Write an expression for a prime and find a prime of 2. So let me see, let me write that down. B is a of x is 3x cubed h of x. Okay, so let me bring that up so you can see it. Okay, product rule. This is 3x cubed times h of x. So a prime of x is going to be 3x cubed times the derivative of h, which is going to be h prime, plus h of x times the derivative of 3x to the third, which is going to be 9x squared. Okay? That statement right there is worth 2 points. 1, because you successfully found a prime. 2, because you successfully used the product rule. So they said any version of successful product rule is worth a point. Well, boom, you did it. Okay, you used product rule. You broke it up with the plus. You've got your derivatives right. Great. Okay, then the next one was for a prime of 2. So this was worth really 2 points. A prime of 2 is going to be 3 times 2 to the third, h prime of 2 plus h of 2 times 9 times 2 squared. Okay, well, conveniently h prime of 2 was found in the previous deal. So this is going to be 3 times 8 times h prime, which I believe was 2/3. H of 2 is 4. So that's 4 times 9 times 4. So anyway, that 3 is going to cancel. I'm going to get 16 plus, how about 36 times 4, which is going to be 144, 160. But quite honestly, if you stopped right there, you got plus 1. If you went to 160, you got plus 1, something along those lines. Don't spend the time typing this stuff into the calculator on the AP test. Okay? Yeah, your calculator is available, it's great, but they don't expect you to use it. Okay? All right, part C, probably the most difficult. As you might imagine, it's worth 4 points. The other two are worth 3. Okay, so it's a little confusing. They're telling you first off that h of x is equal to this when x is not 2, and it's known that the limit of x approaches 2 of h of x can be evaluated using L'Hopital's rule. By the way, you also know that h of 2 is 4. It was given up above. It's right there. H of 2 is 4. Well, that means that the limit as x approaches 2 of h of x is 4. Anywhere where you establish that is worth a point. So anywhere where you let them know that you know that this limit is actually supposed to be 4, no matter where you use it or where it comes into play, that's going to get you a point. All right. Now, the fact that they know it's L'Hopital's rule, what that means is that you should see that when you plug 2 and 2 into the numerator and the denominator, because, all right, let me bring this up here. So we have h of x is, I believe, x squared minus 4, 1 minus f of x, quantity cubed. Let me double check and make sure I wrote that down. Okay, I did. That's proper. Okay, so if we know that this applies to L'Hopital's rule, and we know that we're dealing with this, the limit as x approaches 2 of h of x, okay, well, that means plug 2 in. Well, 2 squared is 4, and 4 minus 4 is 0. The only way L'Hopital's rule does not apply, or applies now, which we are told it does, is if the denominator is 0. And that's key for moving forward in this problem. To understand that, well, since that's 0, that's 0. And so right now, you could say, oh, I can get f of x, okay, or that f of 2, sorry, this is 0 when x is 2. So right now, I could say 1 minus f of 2 to the third power is 0. And that's because L'Hopital's rule applies. Because I'm told that. And the only way L'Hopital's applies is if you've got like infinity over infinity or 0 over 0. Well, by us seeing that that's 0, it means that's got to be 0. Okay? So that's how we're making that jump. And then we could move that 1 over and we get f of 2 to the third power is minus 1. That means that f of 2 is the cube root. Oh, this is negative. So we're going to make those both positive. It's going to be the cube root of 1, which you could leave it right there if you wanted. Or f of 2 is going to be 1, that's worth a point. Okay? So we're up to 1 point. Okay? The next point, okay, L'Hopital's applies, and we need f prime of 3, or f prime of 2. Well, let's do this, and let's take the derivative of the numerator and the denominator, and say that means that 2x over 1 minus the derivative of that. So that's going to be negative 3 f of x to the second power times f prime of x. Now there, right there, that's chain rule. Okay, so the derivative of 1 was 0. We dropped the 3, the cube. The cube came out front, so that's where this 3 came from. The 3 dropped down to 2. The inside stayed the same, and then f of x became f prime of x on the outside. Now that's L'Hopital's rule, that's us applying L'Hopital's rule, but we also know the limit is 4. So if we did this, equals 4, that's a point. Actually, that's 2. And the reason that's 2 is because you've applied L'Hopital's rule and set it equal to the limit. So they were giving you 1 point for that and 1 point for that. Now I might have missed some of that on some of your gradings. And again, that's going to come down to the clarity. I wasn't able to see the work laid out nice and clean. Okay, so it's really, I think, imperative in this new little format they've got that we deal with that. Okay, now we know that f of 2 is 1, I believe, right? And I got a problem. It's not an x. Okay, it's not this is bad math. It does not become 4 until I plug in 2. Okay? And so I do know this. I could do this. The limit as x approaches 2 of that equals 4. That could be a part where they catch you on the notation. But now I'm going to plug in the 2 and get 2 times 2 is 4 over negative 3 times f of 2 squared times f prime of 2 is 4, and this is what they're after. So let's see what we can do. I'm gonna multiply both, well, I'm gonna say f of 2 is 1. So this is really 4 over negative 3, f prime of 2 is 4. 4 is negative 12, f prime of 2. Divide both sides by a negative 12. There's your negative 1/3 is f prime of 2 plus 1. So there are 4 points here. And there's a lot of notation that you could screw up, which I did, right? I think that you have to have that in there. Or if you wrote 2 times 2 minus over negative 3 times f of 2 squared times f prime of 2 equals 4, you would be okay without actually taking the time to show that it was the limit. They're going to make that jump for you, I think. Okay. Both of these questions had a part D that were each worth 1 point. They were both exceedingly difficult. I cut them off. They also did not apply yet. They were parts of things that we didn't have to deal with. So that's why these also are both 8. Okay? All right, that's it for that.